Hello everyone, welcome to my talk, No Signal, No Problem, How We Collect Data in the Most Remote Places. I'm Benjamin Monjoie. I've been an Android developer for over 15 years now, and I'm working on a project called IASO, developed by Blue Square. It's a company in Belgium. And in this talk, I will present you the work that I've been doing on this project for over 3 years now, where we are actually in places where we have no internet connection or very poor internet connection, and how like all the techniques and the tools we are using to try and tackle this challenge. I understand that this is the end of the day. You're probably all very tired and you want to go have some drinks or a nice party after. So I'll try to make this as entertaining as I can, so not really. But just to do my best, we will try and play a small game. It's going to be a fighting card game. You won't play, right? It's already won, but for the sake of it, we're gonna just pretend that we're playing it. This game opposes two people who play one another. The first protagonist we have here is Carmen Sandiego. So just for my own curiosity, can you raise your hand if you know this character? Yeah, that's pretty much what I gathered. For me, I thought it was very famous, but so this is Carmen Sandiego. It's a character for a game, I think from 1985. One of the first educational game, and it was quite popular that it actually became a TV show. It was also a game, I think, in Canada, where kids were playing. And so this is this character here. This is the picture that I took from the reboot that they actually have on Netflix. I've heard it's good. So if you don't know, maybe it's worth a shot. I don't know. I haven't watched it yet. So in this, normally she is a thief, but in this case, we're gonna say that she wants to stop you from collecting data. On the opposite side, we have our users. Our users are NGOs, Ministries of Health in emerging countries, governments, and stuff like that. These are actually our real clients. And they have these skills. They are very brave. Sometimes they have to go to secluded places. They even work in countries at war. They are resilient. Sometimes they have to take quads and drive for hours in places where there are actually no infrastructure, no roads. They just go in one direction, and if they meet a river, they have to go around it and find a bridge. And they save lives. Some of our clients fight malaria or hunger or even the sleeping sickness and stuff like that. We are trying to help those people. As I said, there is some roadblock on the way. There could be none or a very poor internet connection. Sometimes when they have no internet connection on hand, they have to walk hours to get to an internet connection, to be able to sync data back and forth. And as I said, they could be in some very difficult situations. And obviously, let's face it, we all do our best, but bugs happens. And so in this case, they are helped by two tools, and I'm going to present. One is ODK that you may have heard of. ODK is a tool that, a company, that created the tool of the same name, that also created the standard code XLS form, which allows people to define the structure of a form in an Excel file, a Google Sheet if you want also. And then this can be after that rendered on the web or in the mobile app. It's very feature rich, it's very powerful. And IASO is based on ODK, which is open source, and IASO is the tool I'm working on. We have added some functionalities to that to be able to help our client achieve their goals. IASO is a distributed offline first data collecting application, as I said, that I've been working on. So now let's look at the game. So how do you collect data without an internet connection? That's a very good question indeed. So we store everything locally. Fight. Yeah, I'm doing the sound effect myself. I know you couldn't tell. So this is going to be the board game. So on the left, we have the extra where we show, the stuff that they can present. So here we show, okay, we collect everything. This is the screen that you actually see when we download everything in IASO. So we download every type of information that we'll need for later. So in this case, the organid types, the organid groups, the forms, the organids themselves. So organids is the representation we have of a country, for example. Let's say that we have a pyramid. Let's imagine we have the country, and then under that you have the provinces, the districts, and stuff like that. And so all of that is downloaded, and a few other things. So commonplace first, and she says, haha, incoherent data. So when you download data from the backend, sometimes, well, the backend might give you some data that is incoherent. And if you don't catch it firsthand, then you will have problem later. So how do you fix that? Well, we can play our cards, which is foreign keys. So what are foreign keys? For those who don't know, we're going to take a very simple example with, let's say in our database, we have a table with a very simple table called users, for which we have an ID and a name. The ID would be the primary key here. And then we have another table called order with the order number, which is the primary key, a product that those users might have bought, and then the user ID. The foreign key says that the data in the user ID field must point to the data that is in the ID in the user table. So let's imagine that we only have one user with ID 124. In the user ID column, we can put 124, that's going to be okay. But if we try to put 123 and 123 doesn't exist, you will have an exception. So back to the game. It says, haha, unclear foreign key exception. So what does it mean? It's like, if you download lots and lots of data which are interconnected, then when you insert those data inside the database will not tell you, this is the row that is misleading. It will just tell you foreign key exception. As we said, our users, they might be walking 7 hours to get somewhere, and you need to be able to help them fast. So if you have that, and you have potentially thousands and thousands of objects to look through, this is going to be a real nightmare. So as we play display meaningful information, and you can see here that I changed it. It's not anymore the exception we saw, but we can say, hey, while downloading the change request, the one with this ID cannot be inserted because this originator is not known. So now we know, hey, the backend should have returned that. There is something wrong. And so how do we do that? So this is an example of what we have more over everywhere in the code, and we're going to go through it very quickly. But so first we see that this is a private function, a suspect function, that receives 2 arguments. Oops. The original exception, and we'll see why later, and the list of DTOs, data transfer objects, that we have received so that we can look through them and figure out which one it is. This also returns nothing. So who of you knows what nothing is? Okay, not a fair amount. I'll just go. So basically, in Kotlin, you have 2 special types. You have any, which is the parent of everything, and then you have nothing, which is the children of everything, of every type. And the good thing with nothing are twofold. The first one is you cannot return nothing. So in this case, putting this, I ensure that in my function, I will not forget to throw an exception. At the end of it, because I cannot return nothing, I have to throw an exception. Another good thing is that sometimes, I'm not showing it here, I hope it won't be too abstract, but so if you are in your code and you want to stop the execution, you can actually return detect foreign key issue. And since nothing is the children of all type, it means that whatever the return type is, you can always return a function that returns nothing. And so you can stop the execution of the other code. And this is where this is coming very handy. Went a bit too fast. Here, so we loop on the entities and we try to find the first one for which we have an unknown organid, because we know that the change requests are linked to organids, and so this must be the problem. And if we find it, we throw an exception. And remember I said we pass the original exception, and we will see later why. And you can see that I use it here. And so why do I use it here? Because you need to remember that when you throw an exception, you can always pass a cause. And what is good with passing the cause is that you never actually lose information. If I was just throwing a new foreign key exception, I would know that the exception would have originated here, but I would not know, hey, what was the original issue? If something else was important in that, I would have lost it. Passing my original cause as an exception, as a cause, is good to not lose any information. And we'll come back on that later as well. And again, because I return nothing, I need to throw the original exception if I couldn't find anything. Why do we do that? Because if I couldn't find that, it might be another relation that I didn't think of, that I know, okay, I need to change this code to detect what's wrong. Okay, and so now we have refresh data. As I said, like, how do we refresh data when you have very poor connection, where you don't have a lot? So we need to make sure that we offer the user the possibility to refresh only part of the data. So why is this important? Because sometimes you don't want the people to download everything again. This is gonna be way too much. So sometimes the user is smarter than you in this case, knowing, oh, I only want to refresh the forms. I know there is a new form, I only need that. And so offering this information is actually very important. And as I said also, like in the parentheses here, sometimes it's a good idea to save the last time you refresh the data, so you can send this information to the backend, and so the backend can return only a subset of the data and only what's changed. But we have on-conflict strategy replace. So what does that mean? When you declare a foreign key, we have two fields here that are on delete and on update. And it's usually a good idea to put cascade here. So what does it mean? It means, like, again, if we take the example of our user table and the order table, if we say on update cascade, and now we change the ID from 1 to 4 to 1 to 3, all the rows in the order table will be updated from 1 to 4 to 1 to 3. And it goes the same with cascade. If you delete something in the user class, all the rows that were pointing on it in the order table is gonna be deleted as well. And so how is that a problem with on-conflict strategy replace? Well, we were updating our data, and we think, okay, if I use room, I can insert an entity, and if it already exists, just replace it. What wrong could it do, right? Well, let's see what happens with this. So we have a user with ID 1 linked to some orders in the database. We want to insert a user with ID 1. So we have a conflict, and on-conflict strategy replace kicks in, and it deletes the existing user with ID 1. Then the foreign key kicks in as well, and all the orders are deleted as well. And then we insert the new user ID. And if you look only at the user table, you will think, hey, it's been updated, it's been replaced. But you actually lost data. So that's the issue we are having here with this. So how can we tackle that? Well, in Room, you can have custom DAO, so data access object. And as you can see here, now we have an insert method and an update method. We can also see that we changed the conflict to ignore. And also the difference is that now we are returning a long. So what does it do? When you try to insert, if you actually are able to insert something, the long will return to you the row ID of the new entity that you have inserted. If something was already there, it will return -1. And we can leverage that to have a new method that is annotated at transaction. And we can say, try to insert the entity. And if it's -1, it means it was ignored, then update it. And now we're not replacing it, we're actually updating it. And so the foreign key will not delete the data. We can have the same with a list of entities. And we can see here that instead of having a long, we have a list of long. And so here, what do we do first? So we try to insert the entities. It will give us a list of long, a list of row ID or a -1. And we can map them and say, okay, for each one of them, we're going to look at the result. If the result is -1, we're going to say, okay, take the entity and put it in the map index. Because it's not null, we're going to take that. And all the other ones are going to be null and going to be ignored. So in the end, the exit of that is going to be all the entities that have not been updated. And then if it's not empty, we can update them. Okay, and so when you download information, well, obviously the data size matters. So one of the nice things you can do is use OKHTTP, because by default, without you doing anything, it will try to gzip your response, and it's going to make it much shorter. Without you doing anything, it's going to be by default. But it's still too big, so what can we do? You can create a zip of your responses. So this is something that we do. We notice that, sometimes people, they go on the field, they have, 20, 30, 50 tablets that they have to bootstrap, And if they have to connect them all on a very bad connection, it takes a lot of time to download all the information. So we had the idea of creating a zip with the response of the backend. So how does it look like? Like you will have a zip file, and inside you will have the app.json, the organize.json, the forms.json, and all of that, which are the response at a certain time. Then your application is able to take that in, unzip it, and have a folder with all the responses. Then, so who of you know of retrofit? Retrofit, the library? Okay, most of you. So I'm gonna very quick on that. So for those who don't know, retrofit is a library where you can just pass an interface that declares how to call your backend. And retrofit will basically leverage this information and generates the implementation for you. So you just have to declare the interface and everything is done for you. So in this case, we have a wrapper around it. So it's a IASO service provider. The IASO service is the interface I just talked about. And we also provide Moshi. For those of you who don't know what Moshi is the same, it's made by the same company, Square, and it's a JSON parser that is very powerful with Kotlin. And so on that IASO service provider, we create a method invoke, and we made it inline and reified. So before I go too much into detail, like who knows what reified is? Not a lot. Okay, so I'll try to explain. So this is a very naive and simple example for you to know, but let's say we have a generic method, getName, that receives something, a T, and you would say, hey, I would like to know what's the name of the class of my generic type T? And you can see here that it says like, this cannot be done. And you should pass the class instead. You should pass the class directly. You cannot ask the class of T. And so why can we not get the class of T? Because Java has something called type erasure. So at runtime, Java has no knowledge at all of your generics. It only knows at compile time. And so when you are there, at runtime, Java doesn't know what T is. It has forgotten. It would always be object and not the actual one you have. But when you do now inline fun reified, it doesn't complain anymore. So what's happening here? So when you have the keyword inline in Java, and this is one of the important bits, inline will take the code that you have there and copy it at the calling site. And as we know, at the calling site, we know what class it is, because at the calling site, we will know what class we want. And so Kotlin, with the reified keyword, will actually replace T by the real class. And so it's some magic trick that the Kotlin compiler does for you, which allows you to use T class. And so that's why in my example before, here, we use inline reified, because we'll see we need this information about what is T. This method receives a folder, the folder where we have potentially unzipped our content, and the name of the file we want to parse. And if we don't have a folder, it has a lambda to call the backend. So how does it work? If the folder is not null, we're gonna call moshi.adapter. And this is a inline reified method. This is why this was important before. And this will take care of leveraging the info about what T is, whether it's a collection or whatever, and get the right adapter to transform your JSON into the object that you want it. And so as you can see, then we get the source from the file that we passed, and we require it not null. And otherwise, we invoke the call. Here I'll pass is just some syntactic sugar to call the method. And this is what it looks like. As you can see, we received a service provider, and on the service we invoke. We pass the folder and the file that we would like to find in it. We pass the method on the interface, and then we can get our file. So as you can see, it doesn't add a lot to your use cases to actually being able to get the response from a file. But then again, when you have 50 tablets that you have to set up, you can send one file, and it's a lot faster for everybody. So again, what did we have? We had incoherent data, the foreign key exception. So what's important is try to make sure that the data is sane. that you, if you have an issue, try to be able to figure it out quickly so you can fix it quickly for your users. Try to refresh as less as possible. Keep in mind that strategy replace might be a bad idea. And try to make it as small as possible for your users. And how do you share data between your users when you don't have an internet connection? Because now here we can imagine that we still had one, except for the zip response. But like now we are on the field, we don't have an internet connection. So how do we do that? So we don't have an internet connection. We can use the nearby connections API. Nearby is, so I put the link here for the code. I'm not going to go into detail because it's quite big. For those of you who saw the talk about BLE, it's kind of thing like that where you have to start a connection and all of that, and we're going to see that. But so Google has some very good tutorials that take you through it. And I'm going to just explain how it works so that maybe if you ever go there, you're going to know what to expect. So you have two phones and they have to connect to each other. And Nearby is a library that Google made that is leveraging Bluetooth and Wi-Fi so that device can connect to each other, and it's all made for you. So the way it works is you have one device that's going to start to emit, say, hey, I'm ready to connect to someone. Another one is going to listen, and then when it's going to find the other device, it's going to request a connection. Then both devices will have to accept the connection. So you can present to your user, hey, by the way, this person is trying to connect to you. So do you accept? And if they do, you can send the payload to the other one. It can be byte arrays, it can be streams, it can also be text. And it's very efficient to send data to one another. Okay, but so what if devices are not next to each other? How can you share information? So the use case that we have here is that we have some people who benefits from food help. And sometimes they need to go to one help center, and then they need to go to another help center. The problem is they don't necessarily have internet connection in those centers. And so how do you send someone somewhere and be able to pick up where you left off because they don't have internet connection? So in this case, we went with NFC cards. So NFC cards are cheap, easy to use, and easy to carry. They look like your credit card. But on the cons, they cannot store a lot of information. I think one of the best, like the biggest we use is like 16 kilobytes of data that you can store on a card. So that's not a lot at all. And they're easy to lose. And some are, so like if you use the basic stuff, they could be easy to copy. And we don't want that. We want people to be able to cheat the system. So, how do we store the data on an NFC card? And we decided to go with the standard, which is called NDEF, so NFC Data Exchange Format. And why did we do that? Because it, as the documentation says, it has to be supported by all Android devices with NFC capability. It is a mandatory for every phone that have NFC to support that. So we ensure that this is going to be compatible no matter what the phone we have. It's easy to use. If you ever played with technologies like that, if you want to actually do NFC yourself, you have to page through data and byte and all of that. It's very hard. NDEF takes care of that for you. And the overhead of the data that you store in it is negligible. We have the a header byte, which is 1 byte. We have the length of field, then the payload, and the name. So I think like when we calculated, we had like something like 12 bytes, which was okay for us in this case. And as I said, you can easily store byte arrays. So how do we do that? So we use protobuf. Who has heard of it? Oh, a lot more. I'm impressed. Okay, so for those who don't know, protobuf is a protocol that was developed by Google. You have also the link for the documentation at the bottom of the slide. And it's a very lightweight way of transferring data. It's in binary, and the goal is to be as lightweight as possible and still be generic. So yeah, we can store values in byte arrays as effectively as possible. It's based on a schema. It means that when you store the data, you need to know the structure of the data you want to store, and when you retrieve it back, you have to know it too. So they are called messages in protobuf. But what's important is that those schema can be dynamic, and so you can generate them on the fly as well. And I'm not going to go through them all. We're going to see later why it's important. But so for every field that you store on it, you're going to use 1 byte to the number of field, because basically, based on the schema, if you have name, first name, and stuff like that, it's going to store with numbers. So name is going to be 0, first name is going to be 1, and this is how it knows where to get the information. Boolean is 1 byte. The integers can vary between like up to 10 bytes. The fixed one are 5 bytes or 4 bytes, and you can see we have this information, and so it's very efficient. But the data can still be too big. And one of the things we did is try to optimize how we store data in protobuf. And if we read again some things like bool is always 1 byte, but the Boolean can have 2, maybe 3 value if you consider null. Null, true, and false. So that's 2 bits. So why do we take 8 bits for 2 bits? And we can see that integer are 5 bytes. So it means that if we have null, false, and true, it means we could store 16 bits in 32 bytes. So we could store 16 bytes in 5, some sort of. So how do we do that? How do we store bits in an int? So again, for the representation here, we have the 3 different values that we have. And we can say we have a representation of a 0, 32 bits integer. So for clarity's sake, I put plus 22 because I didn't want to put 32 bytes on the slide. And then we have the representation here of true, which is 1 and 0. What we can do is we can use the logical operator OR. And so what's going to happen is going to say 0 or 0, it's 0. 0 or 1, it's 1. And then 0 or 0 until the end, it's 0. And so now the result is we have 2 bits inside the integer. Okay, but we want to put more, right? We want to put like up to 16. And so, okay, we have the previous value, 1 and 0. We have the new one, 0 and 1. And so what if we do OR? And then if you do OR, we have 0 or 1, 1. 1 or 0, 1, and then zeros, and we have 1 and 1. Like, so what is that? This is not what we wanted. We are not storing values. So how do we fix that? We fix that by taking the representation of what we wanted to put, and we're going to shift it. We're going to shift it to the left. So Kotlin has its shift left 2. We're going to move it 2 bits. And in Java, it's the smaller than, 2 times smaller than symbol. And so now we shifted the value. And if we take the previous value, and now we do OR, now we have successfully stored our 2 Booleans value into that. Okay, so but how do we retrieve this information? Okay, because now we have it in there. And so now we do the opposite. We say, okay, we want the first one, we want the blue one. And we need to take a mask. We're going to take, so the mask, we want only the first 2 bits. So we put 1 in those and 0 to the rest. And this time we use AND. So 0 and 1, 0. 1 and 1, 1. And for the rest, 0. So we have our representation. And if we want to get the green one, we use shift right. We shift the information to the position we want. We apply the mask with AND, and we have our representation. Easy as pie. At least I think it is. So, and this is how we actually, so in our case, the forms, they had a lot of these Booleans. Simple question like, does this person has short of breath? Are they vomiting? Yes, no, yes, no. And so we were able to actually reduce considerably the amount of space we were using per visit stored on the card. But like also, as I said, it's important that people cannot like retrieve this information. There could be important information, private information. So how do we do that? We use encryption. So here, I put the current standard that we are using. So there are lots of examples, and I don't think that it would be very useful to go through details about what's the code to generate the key and all of that. But so you need to know that at the moment, we are using these recommendations because they come from the NIST, the National Institute of Standard and Technology. And I put the link here to the latest publication. And I don't advise you to take those as is, because obviously security evolves all the time. But I put the information there in case you want to know. And so, yeah, this is one way, and this is one of the way that was recommended by the NIST. But it's always important to go to a trusted source and not just blindly follow what you find on Stack Overflow, because it could be outdated. This is the message I wanted to send here. Also, as I said earlier, well, the keys, if you use software encryption, the card can still be copied. You might not be able to retrieve the information on it. You might not be able to change the information on it, but you could still copy it. And so there exist some physical ways to actually talk to the card and make sure that the connection with the card is completely encrypted and that the password is actually stored in the SIM. And so the SIM here is a SAM, Secure Access Module. And so some devices come with that, but if you want to be compatible with the devices that are out there, most phones don't have a module for that. But so if this is a requirement, know that it exists. Okay, deploying new APKs is slow and heavy, so how do we tackle that? No, we're not out of ID yet. So as you saw, the sound effects are broken. It's a bit hot. So the thing is, since we are offline, something that you may understand, like in most recent modern application, what you will notice is that you usually give all the responsibilities of the logic to the backend. You will try to put as much logic over there. It's very good for you because then your sprints are shorter, the work and the responsibility is on the backend team, and you can focus on making the application look nice. But if you don't have an internet connection, you cannot do that. You need a way to have the logic in the application, and you need to be able to update it fast. And so for that, we use something called JSON logic. It's a way for the backend to be able to generate some logic that can be transferred and serialized to the mobile phone. So how does it look like? Again, the website is there. There are implementation for lots of different technologies, so Python, JavaScript, Java, and all of that. And so you always have an operator and values. And so you can see the first example is we have the operators equals, and we say 1 and 1. This will return true. And we can say and, then the values can also themselves be JSON logic. So we see that 3 must be greater than 1, and 1 must be less than 3. And you can pass data to change, like to compare. And so in this case, if we see that the temp is 100 and the pie filling is going to be apple, this is going to be true. And so with this, we were able to provide some logic from the backend, because our application is agnostic of the data. As I said, the formulas, the forms that we received are XLS files, and the application is agnostic of what's inside until it displayed them. And so thanks to that, we received the logic to apply some things, and it can be easily updated by the backend. And it's very light, instead of having to hard code in the application some logic. A bonus, something where we didn't use, but it's something to consider as well, is Zipline. It's a library made by the people at Square in their Cash App application. And then you can actually code in Kotlin JavaScript, and it can be fetched from a server, and it's much more powerful. But yeah, much more powerful, but it's heavier. You need to embed a JavaScript engine. There is more work to set up, and the logic cannot be generated by the backend, as far as I know. We also use HTML pages. This is a combo. So I'll go a bit faster because I think I'm going to be out of time. So if you want to do that, you have to create a web client that looks like that. Inside that, you have a property asset loader. And you can see that we add a pass handler. And we say when you hit /webview/, you need to find the folder called webview in the files dir. Then in the web client, you override should intercept request. You can ask the asset loader, hey, should I intercept that? We also can return a JavaScript interface. The JavaScript interface, you need to annotate the methods that you want to be accessible from the JavaScript to be able to talk to your app with this JavaScript interface annotation. And in this case, for example, we return some information about the application. If we look at what it does, we say, I have some JavaScript. We can add the JavaScript interface. When we load the URL, we have this special app assets androidplatform.net URL that we have to pass, and then the /webview that we mentioned earlier. We can also say we want to be able to debug those. And like that, if you open a Chrome browser, you put this in the URL while you are on your web view, you will be able to inspect what's inside your web view. And just like it would be in any Chrome web page. And remember I said like, we have this .info method, and so if on the web view we add an interface and we say you're going to be able to call it with Android, in the JavaScript you can do android.info, and that will call the method I showed earlier. And again, we load the same specific URL with the /webview, and this will be it. Yeah, sometimes you will have complicated logic, and as I said, bugs can be very problematic on the field. Some people, they go for months without an internet connection. You cannot necessarily deploy a new APK, so you have to test your code. So in this case, well, I just wanted to mention it. I don't think I can explain in 5 minutes what tests are, but again, you need to think about all those are super important, but unit tests, the shorter tests, they are easy to write. They are faster and cheaper. And so that's why usually you see this pyramid. Integration tests, which are a bit more involved, obviously they are somewhere in between. And then when you want to go full UI test, well, they are slower to write, slower to execute. They are more expensive. So I would advise to unit test as much as you can, and then write UI test and integration test for your most involved scenarios. Sometimes it's hard to debug, so you can log everything. One of the things we did, and I'm sorry I'm going to have to go a bit faster on that, is if you use Timber, you can actually use a file, the rotating file, to actually write all the logs you write to Tinder into a file and then share it easily later. And so this is the code here. That can be found online as well. Okay, and now, how do we send the data to the backend? So the backend, sometimes, so I said, people, they work 7 hours, they go where they have to go, and they will sometimes have errors from the backend, whatever that is. And so what do we do in those cases? We do not return errors. And now I think you say, what? And so again, don't forget that your user, they may have worked several hours on a weekend only to be greeted by an error. And so in some cases, not all of them, it's not always mandatory to return an error. What we saw is that sometimes in certain conditions, we can detect that those errors are something that we can fix later. And so it's much better that the backend will store this information that it has received and realize, okay, this is something that we can fix later. We can figure out this problem, and then import it at a later time. And how do you achieve that? By logging everything and having proper scenarios in place for this kind of exception. So of course, sometimes you will have to return errors because you don't want to be in a scenarios where they think their data is safe and you actually don't know what to do with that. But for those cases that you have identified before, you might not have to return errors. Here we have something that is actually a screenshot we had from one of the clients in DRC. So And they were saying it takes too long. And so let's look at the screenshot here. And you can see the descendant and ascendant speed are okay. So like, why does it take too long? And then you look at it and you say, oh, wait a minute. The pings here, we have 3 seconds to establish a connection, to send something, so per connection. And that's what got us, is like they were coming back with months of data. And the legacy code that we had was sending data like one at a time. And so it was taking a lot of time because every time the connection was open, sending the data, connection was closed, we mark in database, okay, we sent that one, and then we open the connection, and every time we added 3 seconds. When you have 120,000 things to send, it adds up. So how do you fix that? Make less call. Try to use reuse connections, especially with HTTP2 and stuff like that. You can do that. And so in our case, we created a zip file of everything, and we send it. We split the zip so that it's not too big, and we managed to fix the problem pretty quickly. Okay. So in conclusion, I hope I didn't bore you to death. But what's important to know is that working offline is a lot harder because you face challenges that you don't face in any other scenarios that you are used to. We have to put lots of logic on the client side, and it's a lot harder to update application. You also need to think about never deleting anything, because it's very important that if you're, like, again, you know, someone, they go on a mission for 2 months, and then they come back, and then you lost everything, it's a big deal. People might be dying because of that. You may have ruined like a whole collection. So never delete anything. Make it sure that you can retrieve those data if something wrong happens, even if they have to send you the phone. And log as much as you can. And obviously, test. That's it. Any questions?
Hello, thank you for the talk. I have 2 questions actually. The first thing about the optimization, micro-optimization for protobuf, I'm not sure where you put the optimization, because I know like it's generated code at the end. So where the type is translated from bool, or like or you are just using an int and that's something you are managing in the code?
Yeah. So.
Yeah, okay.
Yeah, sorry. I understand it was not very clear what I said. So we store the forms whether we receive, and so we have questions. And so what we did is before we create the schema for protobuf, we look at all the questions that are yes or no question, and we extract those, and then we create the schema for all the questions that are not yes and no question, and then we create chunks of those, like packs of 8, or I forgot how much I said. Like, that's it.
And my second question, sorry, it was why using TCP at the end if you are trying to cutting the round trip cost for your connection? Why don't you use like something else, another protocol instead of TCP/IP? Because if you are using Quick or stuff like that, you will gain a lot to avoid what the round trip is costing you.
One of the reasons we used TCP for that is, so I'm not sure this is exactly your question, but I think it's also relevant. So why would we not want to use UDP, for example, is because we want to make sure that the data arrives safely, right? So for those who don't know, just TCP and UDP, so these are the protocols that are used by the internet, and TCP is a bit slower because it sends the data, and then it says, hey, did you receive it? And the other one says, yes, I did receive it. And so then it considers it's okay, otherwise it will send it back. And UDP is something that's send, and I don't care what's come back. So obviously, just doing send is much faster, but you don't have any guarantee that it's coming back. Then I'm guessing your question is why use HTTP rather than using something like, yeah, exactly. Or I'm looking for the word. I'm blanking here, but a socket, or for example, yeah. So because the problem that we faced as well was that we had to send lots of information that had to be also like processed by the backend. And so we didn't want that the sending the data would be slowing down the backend. And we thought like having a big zip with everything, sending it would be faster. And also then the backend could put that and say, okay, I'm gonna treat that later. And we have the data, the zips saved. And again, we don't delete anything. Does that answer your question?
I had a question about the data storage, because you said you try and log everything, and you try and not lose any data. Do you have any strategies, or did you encounter any issues with devices that run out of data? I know that old Android devices that store in /data had like some limited size often. So is it something that you encountered?
No, we store on the SD card, this kind of things. Also, like depending on the client and the situation, we will make sure that they have the proper thing before the collection goes. In the scenario that we have, often these are governments and they decide to buy like a certain tablet in bulk. So we know in advance what kind of data we can have out of that. And again, we decide not to delete anything that we could not save before. Once we know for sure it's saved, you can delete, even though we are still scarce about that, right? Because of the reason I explained. But no, we have never actually had a problem with storage because we don't store lots of information like pictures or videos and stuff like that. So it's fairly light in our use cases. We collect data, so we still have some pictures and stuff like that, but it's never been to a point that it would fill the external folder.
There's a lot of sort of open source frameworks that people would consider standard for Android development that then make assumptions about having signal, analytics, bug snag, crash, all of these sorts of things. Do you have a particular technique for handling that, or is it just a case of if the library doesn't let you use it offline, write it yourself?
Well, in our case, we use Firebase, and Firebase has something that it tries, like when you have a connection to send the logs. So as far as I know, it has never been an issue for us using Firebase. But part of the logging everything, we recently implemented something that's not out yet. But I made a little library that allows you to shake your phone, and then it will actually take the log file that I saved. It's going to take some information, and also like all the logs that we pass to Firebase, we also store that. I think the last 20 or the last 50, I forgot the exact number. And then when you shake your phone, it takes that, put it in a file, and then it offers to send it via WhatsApp, email, whatever. So that if there is really something that they don't know what happens, they can shake their phone and send it. So in this case, we developed something for that. But for the crash reporting and all of that, we rely on Firebase, and we haven't had any issues so far that I know of.
Thank you for the talk. Also, I had a question about the inconsistent data. What do you do if user updated some data, then couldn't send it, then it was updated from another source, and then the first user is trying to sync the data? What will be taken as the source of truth? What will he see? And so on? Yes, this is a very hard problem to which we have not found the perfect solution, and I don't think we will. So again, we never delete anything, right? So even when we receive contradictory information, we will still have the information that something was sent. But on the backend side, we decided that the easier solution is to consider that the latest information is the most current one. And when I say the latest, I don't mean the one that was received the latest. The ones that the created date, or the updated date that we stored on the local phone is the latest one. If we take, again, the example of someone who goes to a health facility to receive some food, right? And so then they fill the forms. You are elected to receive some food. You get the food, and then you are sent somewhere else for the next one. And then the next one, they have an internet connection. Let's say you also get that. This one sends the data, and then the one here sends it as well. We consider that okay, since this one was created after the data from the first health center, this must be the correct one. And if there is an issue, we can go back because we always keep everything that we saved. And so if we have an issue, we can go look at the data and fix it ourselves if needed. So far, it has worked fairly well. Yes, we save created date and updated date for everything that we do on the phone, and we send that to the backend as well.
Thank you for the presentation. I've got actually 3 questions, but let's see how many I have time to ask. The first question, do you support all Android devices, all Android OSs, or just some particular devices and some particular OSs?
So it's always a hard decision to make because we are in emerging countries where people don't necessarily have a lot of money to pay on phone, and sometimes we have some campaigns that are bring your own device. So it's always hard to figure out when do you cut on the older devices, and so far we support Android 5 plus, and sometimes it's a struggle. But we try to think, okay, unless we have a real requirements that's going to bring us to something later, we will try to keep it that way. So to be fair, we need to look at the numbers to make sure that we are not, doing all this effort for 3 phones. But so far, it's not been that much of a hassle that we had to look and think, okay, do we really need to update?
Yeah, thank you. Can I ask a second question?
Yeah, go.
Do you distribute your applications through Google Play or some other way?
So it depends. So IASO, the application that I'm working on, is on the Google Play. We have also many clients that want their own branded version of it. So we have a different version, and where it's hard that sometimes, before we update another version, we have to go to the client's approval. So we have many different versions on the store, and that has been sometimes also an issue, trying to maintain different versions of the application. But so, yeah, we distribute it like that. And sometimes we distribute it through MDMs. So we have one client, for example, that they have their own repository with the code, and they build it, and then they upload it through their own MDM and build it themselves. I think I held you long enough. Thank you very much for coming.